not have said equation. What's the first thing you should find? I think that's the logical place to start. It's kind of hard to find the y-intercept. Too many unknowns over here if you try to find the y-intercept. It's probably easier to find the slope first, so let's start with that slope. With a marker that writes, perhaps. Yes! Yes? So start with the slope. Slope, which is the grade. Yes? Slope is grade. What's grade? Rise over run. What's it rise, friends?
9.
Good. 9 what? I want to focus on units too. Now that your next project isn't due for a couple weeks. We want to focus on units. 9 what? 9 million more people. Yes, it rose 9 million people. It's a rise of 9. And it rose from 35 to 44. That's a rise of 9 million people, correct? Yes, this is 9 million more. So you got 9 million people over the run. What did it run?
8 years.
It ran 8 years, yes? Because you started in 1992 and you ran all the way to 2000. So that's 8 years of run. So it ran over the course of 8 years. This is getting hard to see because I got to replace the ink in it. So I'll switch over to green. Nah, I'm already using green. Purple's red. Purple's dead. I don't know what happened to it. I must have dried out. It's okay, we'll use red. All right, so the slope, therefore, 9 million people over 8 years becomes 9/8 or 1.125. What do you guys want, fractions or decimals? What do you want?
Fractions.
Fractions? Okay, so 9/8 million people per year. So what does that mean? 9/8 million people, or 9 million people over 8 years. Or per 1 year, it would be 9/8 million people per every year. What does that mean? What is that telling you about this line that we have decided upon? What is it telling you? I'm looking for a statistical word here. It went up, right? It went up 9 million people over the course of 8 years. So when you knock that down to simply 9/8 or about roughly 1.1 million people per year, what is it telling you? I'm looking for a bit of a statistical term here I'm going to keep using as we go through the term. It's the average growth per year. See the per year right there? Per year? It's saying that assuming that we smoothed out the growth into a perfectly straight line, assuming we smoothed out the growth into a perfectly straight line, you would have to grow at this rate every year to get from this point to that point. Is that what actually happened? Year to year? It did not, did it? Year to year, it was fluctuating. Sometimes it grew more slowly than that. Sometimes it grew up from that. Take a look at the original data again. Okay? So there's the original data. Assuming that it grows at 9/8 million people per year, we have data every 2 years, correct? So what's 9/8 doubled? It would be 9/4, which is 2.25 million people every 2 years. So did it go up 2.25 million people from here to here? Is that up 2.25 million? It's up 3 million, right? 35 to 38? That's up 3 million. So in other words, 2.25 is a little bit too low. Fair enough? How about from 1994 to 1996? Did it go up 2.25 million? Only 1 million. How about 1996 to 1998? Did it go up 2.25 million? Oh, it went up 2 million. How about from 1998 to 2000? Did it go up 2.25 million? Went up 3 million. Well, yes, it went up more. It went up 3 million. But the point is that it doesn't have to go up 2.25 every single 2 years. But over that time, if you want to use this model that we sketched in, it averages 9/8 or 1.125 million people per every 1 year. That's the idea of a slope when you're applying it to data. It gives you an average rate of growth. On average. There were some because there were some 3s in there, and there were some 1s in there, and there were some 2s in there. If you average all those rates of growth together, you're going to end up with this slope right here. So your slope, think of it as that. Think of it as that. I'm going to put this over here because I think it's important for us to take away as we go through this course.